Our first lesson is evaluating a function. This isn't technically calculus, but it's good foundational work for limits, which we'll be doing in the very next lesson, or at least starting in the very next lesson. So in this particular video, I want to look at how to use function notation to find the value of a function at specific numeric or non-numeric values. In other words, just plugging in constants, but also when we plug in variables. So here we have a function x squared plus 7. Now we've got to figure out what do they want when they ask for f of 1. Well, we had a function f of x, and that equaled x squared plus 7. So this is f of 1. So notice I'm saying f of 1, not f times 1. This isn't multiplying f times 1. This is plugging 1 into the function f. So if you think about it this way, there was an x in the parentheses, now there's a 1. So what they're telling us to do is substitute 1 in for x. So we'll do that on the right side as well and replace the x with a 1. So we get 1 squared plus 7, and we get an answer of 8. Okay, next we have 3a in the parentheses, but the process is the same. We plug in 3a for x. Make sure you square the entire thing because you're replacing x with 3a. So x is getting squared, so 3a, the whole thing, gets squared as well. You get 9a squared plus 7. Same here with b minus 1. You will plug b minus 1 in where x was. When you do this, make sure you do not just square each one individually. That's not going to work. You have to FOIL it because squared means times itself, so it's really b minus 1 times b minus 1. So we square b minus 1 times, or do b minus 1 times b minus 1, b squared minus 2b plus 1 plus 7. So just simplify, that will be plus 8. Now this last one is a function that will actually be important if you stick with this long enough to see derivatives, but for now we'll just focus on using it to practice function notation. So there's 3 parts to this. I just underlined one of them in blue, one of them in red, and the third part in green. Now the first one in blue says f of x plus h, so it's telling us to take the function and plug x plus h in for x. So I'll do that. I'll plug x plus h in for x. So what I've underlined in blue on the left corresponds to what I've written in blue on the right. Now the next part I've underlined in red, minus f of x. Well, we know what f of x equals. It equals x squared plus 7. So subtract x squared plus 7. Now you do need the parentheses around the x squared plus 7 because you're subtracting the whole thing. So make sure you write those parentheses. Finally, I underlined h. Well, h isn't a function, it's just a variable. So there's nothing to plug it into, it just stays exactly like it is. And that would be our final answer. Now you could simplify this, and if you really want to, go for it. But for now, that's all you need for me, is just to be able to plug it in and start there. Now I also want to talk about function notation when it comes to piecewise functions. You see an example of that here. This is number 20 on page 27 of our textbooks, if you care to look there. If not, the function is over there on the right hand side. Again, it's a piecewise function. So it says that the square root of x plus 4 is what we use if x is less than or equal to 5. But if x is greater than 5, then we have to use x minus 5 squared. So piecewise function pieces 2 different functions together. We use the top equation when x is less than or equal to 5, and the bottom equation when it's greater than 5. So f of negative 3. Negative 3 is less than negative 5, so it corresponds to the top equation. So I do 3 plus 4, negative 3 plus 4, which is 1. And then we look at b, it's f of 0. So 0 is also less than or equal to 5, so it also will go in the top equation. 0 plus 4, square root of 4 is 2. Okay, f of 5. Well, if you look, the top equation has the option of or equal to 5. The bottom equation doesn't. So once again, the top equation is the one we plug it into because it's less than or equal to 5. Square root of 5 plus 4, square root of 9, gives us 3. Now finally we come to D, f of 10. 10 is greater than 5, so it has to go in the bottom equation. So we plug it in for the x in the bottom equation. We end up with 5 squared, which is 25. There's a place you can look for some examples in your book.